Okay. Hi, everyone. So I just returned your exams. You guys can take a look over them. Um, I was really happy with most of how you guys did. Where um, and those of you, some of you who maybe didn't get as high score as you wanted, I actually was really happy to see that several people were able to answer a bunch of questions very well, but then uh, a few questions that you guys needed a little bit more practice on. So I think for most students that maybe didn't pass the test, or I think maybe I set the threshold of like below a 13, um, and especially if you were like below a 10, um, please upload uh, please upload your corrections, and also you can use the exam answer key or the Google Forms. If you submit the Google Forms, you'll actually see all the correct answers after you submit, I think. Um, so you can use that, and I need to still post the notes when we went over the exam. So you can use the notes and just write out the solutions to the test, showing me that you kind of know the steps, and you know also how I want the algebra to look. There were a few students who maybe got the right answer, or got a little bit lost because the way you were writing it was a bit confusing. Um, and you can also email me if you're struggling with some of the questions specifically. Uh, and so for almost all the students that I asked to submit corrections, I'll ask you to submit corrections. You can just upload them again. You can resubmit as part of exam two upload. And just I will look over them, and then we can schedule a time for you guys to do a retake. Um, so I think there are maybe about total uh, maybe like 10 to 15 students that I think would benefit from a retake. Um, and the retake, I'd like to, because we're doing a new topic now, so maybe the retake could be something we do after Thanksgiving. But if you feel like you're ready and you finish all the corrections and you really know the stuff, just email me, and maybe I can set up a retake sooner, because I know sometimes if you feel like you have it fresh in your mind, you might not want to wait until after Thanksgiving. Uh, okay, do you guys have any questions? Anyone have any comments or questions on the exam? And the best place, it's better to, if you have any questions, it's always better to email me, or because sometimes in the individual comments, I might lose track of them, because I don't get all the I get the notifications, but it's like it can be hard for me to keep track of the notifications of the individual comments. Let's see. For the homework, can you get over 13? Gabrielle, what do you mean? I think the homework is always out of 10.
No, I said go over and I typed it in wrong. Like,
Got it.
my bad.
No problem. Yeah. Well, let me see. What the homework was. Look up the homework here. This was 8.6, number 13. Oh yes. Let me just see if we might not have gotten into all these sections yet. So. This will be the goal for the week, is to kind of do some stuff about matrices. So let me see if 8.6, number 13. Okay, yes. Let me see which homeworks. I will grade all the homeworks. Let me see. I think I'm behind on that. Okay, yeah. So I'm behind on 2 homeworks. Basically, if you turned it in, though, you will get full credit. So that should help give you a little extra points on the overall grade. And by the way, you can check your overall grade in the app somewhere. there's like one, if you hit like maybe my class or something, you should be able to see your overall grade. I think. I did set up that for you guys to be able to check your grade. Let me see. Okay, 8.6 number 13. Yeah, let's try 8.6 number 13. Let's do it on the grade portion. I was wondering if yeah, so first, if you have some questions about like where you went wrong, you can email me. Also, take a look. A good thing to do before you shoot me an email, if you want to see kind of where exactly what you went wrong, which questions didn't have the right answers, just go to the Google Forms and submit the just submit that, and that'll have the answer key there. I think you'll be able to see the answer key. So if you fill out your answers, I think it'll give you instant feedback. But if it's not there and you still can't figure out which ones are missing, just shoot me an email and I will. I'm happy to look over it and let you know which ones. Make a comment on which ones were specifically wrong. Okay, let's do number 13, and then I want to talk a little bit more about matrices today. Okay, let me share screen. But overall, I think you guys did really well. There were a few perfect scores and a lot of like 15s and high 14s. So that was really good to see. I think after the practice, you guys seem to really be comfortable with those questions. Yes, I will try to get I will get the whiteboard notes today into the classroom. I gotta upload them. What's this here? Okay. Let me try here. So this is going to be more matrices. Or today we're going to do matrix multiplication. So first, let's do the homework review. And don't worry about 8.7 just yet. That I might push it back because I'll look when that one's due. This is due, what is it? November 6th? Okay, that might be fine. Yeah, I think by tomorrow we'll have learned how to do those. Okay, so let's try 8.6 number. This is 8.6. 8.6 number 13. Okay, so I'm going to write it as a matrix here, as an augmented system. So this will be 3, 2, 2, put the bar for the augmented part, and then 3, and then 1, 2, minus 1, 5, and then 2, minus 4, 1, and 0. Okay. So remember, our goal is to always get a pivot of 1, a pivot 1 into the top left corner, and then use that pivot 1 to erase everybody underneath it. And then we move to the next corner and we do the same thing. We erase everybody above and below, and the last one we erase everybody above. And then at the end, we'll have 1, 1, 1, and all 0, 0, 0, 0, 0, 0. And then this will just read out our answers. So that's our goal. Does anyone see one of the simple operations we can do to turn this into a 1 and avoid fractions? There's a few ways to do it. Nice. Exactly. Archer, Gabby, very good. You can swap the 2 rows. So that's a good operation to look for because it could just make your life a little bit easier. And remember, swapping 2 rows, the thing it actually corresponds to with equations is just like rewriting the order in which you have the system of equations. So you can definitely do that. So we'll just do a row swap. We'll swap R1 and R2. That would give us 1, 2, minus 1, 5, 3, 2, 2, 3, and 2, minus 4, 1, 0. Okay. And now we're going to use this 1 to eliminate the 3 and the 2 underneath it. And let's just try to do it in one step so we don't have to write too much all at once. Or we don't have to write too much over and over. So this will be still 1, 2, minus 1, 5. But the second row, what should I do for the second row? What row should I subtract from the second row? What multiple? Nice. Yeah, it would be minus 3, right? It would be R2, the second row, minus 3 R1. And the last row will be R3 minus 2 R1. Okay, now this is the dangerous part where, you know, if you have extra space and you want to be super careful, you can do it. But this is the part where you have to really concentrate and do it carefully. I might make a mistake as I'm doing it, but let's try. I'm going to try my best. So I'm going to do. I'm taking this number and I'm subtracting 3 times that. So it's going to be, that's going to be 0. This is going to be 2 minus 3 of those. That's negative 4. This is 0. This is 2 minus 3 of those is going to be actually 5. And then this is 3 minus 3 of those is going to be negative 12. Yeah, 3 minus 15 is negative 12. Gabby, good question there. So R2, as we're, I wouldn't say X becomes Y. So X, Y, Z, they're always just columns. X, Y, Z refer to the columns. So X, Y, and Z don't really change ever when you're doing these operations. But when I'm talking about like the different rows, this R2 refers to this one, and this R1 refers to this one. So it's like from step to step, the way I reference the rows refers to the previous step, the step right before. Because R1, R2, R3, they change over time as you do these steps. Okay. So please hit yes if you are okay with this calculation, and hit no if you think there's a mistake or you're not sure what I did. Okay. And let's see. Okay, the next one, Lily says, let's see, it's going to be 0. Yeah, so the next one's good here, minus 2 of those. Hang on. So it's negative 4 minus 2 of those, minus 2, minus negative 4. Oh, wait, what am I doing here? Yeah, no, it's this. Negative 4 minus 2 of these, that would be negative 8. And then it's going to be 1 minus 2 negative 1s, which will be actually positive 3. And then the last one would be 0 minus 2 times 5, so that's negative 10. Okay. Any questions? Oh, a few questions. A few people said no. Please ask me which row or which step, which number, and you can also just use voice. It might be faster. Anybody who said no, are there any questions?
So I have a question.
Yeah.
So when you're using matrices, or obviously, and you know how you did like R2 minus 3R1, do you subtract that, or do you use the numbers that you have for before or after you swapped it?
Oh, okay, that's really important. I'm using after I swap it.
Okay, cool. That's all.
Yeah, so like the swapping is a step. So I have now I have once I swap, R2 becomes R1 and R1 becomes R2. Any other questions?
Okay, so when you put R2 minus R3 R1, I don't understand what that 3 is doing.
Okay, very good. This 3 here is because there's a 3 here and a 1 here. So what I'm doing is I'm saying I'm taking this row, this is R2, and I'm using R1, I'm using 3 copies of this guy to kill off this 3.
Okay, that makes more sense. Thank you.
Definitely. It's just like a shorthand for the regular elimination that we do. Any other questions? Thank you guys for asking good questions there. We go over one more. Yeah, oh yeah, we're not done yet. So we're gonna keep going, right? So just those of you who ask questions, I'm gonna give you a moment. Just actually do the steps on your own. So I'm gonna clear here, and just everyone, please do the steps on your own, making sure you can do the calculations so that you get to the last matrix that I have. And then hit yes when you're done. And I just want to wait a few minutes so that everybody's on the same page. And if you're not, if you're stuck with, you can message me or you can ask on the voice, and I can pinpoint kind of.
How do you want us to show our work for like when we're like translating the matrices? Like, do you want us to do like the putting the numbers together like just on the side, or do you want us to just have like R2 minus 3R1 to the left of the row?
Yeah, so exactly. So if you write this, like if I was grading this, this would be totally okay because you're telling me what you're doing at each step, and then I can check if you did the right thing. Now you don't need to, like on the side, you don't need to do all the like if you're doing the computation, like what is it here? A 3 minus 15 gets you to negative 12. You can just do that in your head. You don't need to write it down, because if you start writing a lot of these steps down, it gets really, really cluttered. So this is you're welcome to write it down, but you don't need to. I won't deduct anything for that. So, but I do want to see the explanation of what your steps are. So at each row, like at each step, if you change a row, tell me, how did it come from? What did you do to the previous rows to get that new row? Does that answer the question?
Yeah, I got it. Thank you.
Cool. Okay. So anyone have? Did everyone else? I'll give you guys a few more minutes. Just want to make sure that you feel comfortable that you can get to this part so far on your own, or just kind of following the steps, but make sure you confirm those numbers.
Can you explain the R3 minus 2 R1?
Of course, yeah. Okay, so we have R3 here. And we have the 2 that we want to kill off using the 1, the pivot, right? So that's why it's R3 minus 2R1. So kind of look at the numbers. Well, these are the numbers we're gonna get, but let's work with these in the second step. So we have 2 minus 2 of these, that's 0. We have -4 minus 2 times 2 is going to be -8. Then I have 1 minus 2 times -1. Oh, I know that's going to be +2, so that adds up to 3. And then the last one is 0 minus 2 times 5. That's going to be, combining those, is -10.
Okay, yeah, that makes more sense. Thank you.
Mm-hmm. Okay, and Kanjit asks, can you show the placement of the 1 and 0? Kanjit, can you elaborate on that? I'm not sure I understood the question.
Like at the end where we're supposed to have like ones in certain positions out of zeros and certain like changing the numbers, like how is it supposed to look like?
Oh, at the very end. So at the very end, we want to get this thing. Oh, sorry. We want to get, we call it the main diagonal from the top left to the bottom right. And we have our answers A, B, C, let's say. Because if you read off what this actually says, this says that X equals A, Y equals B, and Z equals C. So that's like the final, that's like the completed Rubik's Cube, let's say, right? That's what you want to get to. And we do that kind of in a systematic way, starting from the top left, and then going to the next one, and then going to the bottom right. Okay, so now let's go to the next step. The next pivot is over here, a -4. And you could divide everything by -4, you're definitely allowed to, but you're going to get a fraction here. So that would be a little bit annoying. So instead, can we use this pivot -4 to clear out? The most important thing with these pivots is to always clear out the people on the numbers underneath. So can we use the -4 to clear out the -8 pretty easily? Nice. Yeah, we times it by -2. Perfect. So let's write everything again. 1, 2 minus 1, 5. 0 minus 4, 5, -12. Usually if there's a number like that, -4 in the pivot, I try to divide, but I don't want to get a fraction. So I'm gonna save my dividing for later. And then I'm gonna get here, I'm gonna do R3 minus 2, subtract 2 copies of -4, that'll become +8. So this becomes 0, 0. And now we have to be careful here because it's easy to get mixed up. This is this number minus 2 of those. That would be 3 minus 10, which is -7. Okay. And now we have -10. Oh, sorry. Yeah, minus 2 of those. -10 plus 24 would be 14. Okay. And just hit no if you have any questions, or just speak up, hit the space bar if any question that you have. All right. And those of you who feel comfortable with this, just please keep going, keep trying to move forward on your own. You don't have to just follow my steps. Okay, I will now divide the -7, turning that into a 1. So that will become a 1, 0, 0, -2. And now I have the information that Z equals -2. And what we're gonna do is we're gonna kind of work back up. So this is 0, 1, 2, -1, 5, and this is -4, 5, -12. So this is just going to be R3 divided by -7. All right. And now I can use this one in this pivot to erase everybody above. And that will hopefully make this, this will allow me to make this a nice number. And then lastly, I'll be able to erase that one. Oh. Let's see. Okay, so Gabby asked why -7? Just because I want to turn this into a 1. Is that okay? And then Archer, what did you mean by make the math more obvious? Oh, like the computation. Oh, yeah. Okay. I haven't been doing that. That could be helpful. I just haven't been doing that because I think it would be a lot to write down. But yeah, you can definitely do that. But it just gets way too intense. Okay, so let's continue going here. Now we're going to use this one to clear off everybody above it. Because I still can't get rid of this -4. I can't turn it into a 1 because I still have the 5 there. So let's try it. Let's do, and we're going to do two additions here. We're going to do R1, and I can just add R3 here. And this one will be R2 minus 5 R3. And then R3 stays the same. I don't need to do anything for that. So this is going to be 0, 0, 1, -2. And now it's nice when the last steps are nice because you have these 2 zeros, so they don't affect anything. So this is just going to be 1, 2, 0, -4. And now we just have to figure out these numbers. So if you add them, this becomes 0. And if you subtract 5, that becomes 0. If you add 5 plus -2, that's going to be 3. And if you do -12 plus 10, not a fan of that, but I guess it's not a big deal. Yeah, one of the answers might be a fraction. So -12 plus 10 will be 2 here. So far, does it look good? Any questions?
How do you like know what to do for the matrices? Like, how do you know just like, oh, like add R3 to R1 to get like 0? Like, how do you know when to use what?
Yeah, so okay, so that's a really important question. So are you okay with the fact that this is like our completed Rubik's Cube? This is the configuration we want to get to, where it's 1,
Yeah.
1, 1, and all zeros everywhere.
Yeah, I get that. Yeah.
Okay, so we have like a game plan for these, and then that's how I know what I'm doing, or like why I'm doing the steps that I am. I start off by turning the top number into a 1, either by a swap or dividing or something, and then I use that 1. The reason the 1, we call this a 1 in the pivot. The reason it's so useful is because you can use that 1. 1 is a really easy number to eliminate with. So whatever the numbers are underneath it, you can like swap it. You can like subtract that number of row 1 to turn the numbers underneath it into a 0. Like here it's a 3 and a 2, so I do R2. So I turn these into 0. And then I can move on to the next number, which is the diagonal over here. And you have an option. You don't need to turn it into a 1, but it's just easier to eliminate things when the pivot is a 1. But technically, you don't need to. You can still, in this case, it was actually not bad to eliminate the the negative 8. And then it's nice to turn, so now we've eliminated here, we turn this into a 0. So we just have this number left. And I turn that into a 1, and now I can go start working backwards and eliminate everybody above that 1. And then the last step will be I'll take whatever this number is and eliminate this 2, and I'll be able to get the final configuration. Did that kind of clear up the strategy?
A little bit, but is there like a certain like way you need to move throughout the matrix, or is that just like or yeah, is there like a certain way you need to like do it, I guess? I don't know.
Yeah. Okay. There isn't. There's a few. You have a few choices. I'm just choosing a way to avoid fractions. But there's a few choices you can do it. So you can walk through the matrix. So usually we pick a pivot. We eliminate everybody going here. Then we pick the next pivot. And technically at this pivot, because once you make this if you make this a 1, you can eliminate the number above and the number below. Then you can pick this pivot and you can eliminate everybody above there. So, but it turns out that you don't need to do it in that order. The order that I'm doing here is I'm picking this pivot, eliminating everybody underneath. I'm picking this pivot, I'm not making it a 1, but I'm still able to eliminate the number underneath it. I didn't eliminate the number above it yet. And then I turn this into a 1, I eliminate everybody there, and lastly, I can turn this middle number into a 1 and eliminate the number above. So there's some flexibility. And as you get more practice with it, or to kind of see this example, you start to say, okay, well, let me, instead of like dividing this by like -4 and getting a weird fraction, and then let me just see let me eliminate as much as I can, and then see, hopefully towards the end, I'll be able to get nice numbers. Okay, did I make a mistake here? A few people say they got +2 for R2. -5. Oh, yes. Oh, I'm so sorry. Yes. This is -2. Yeah. -12. Thank you. -12 plus 10 would be -2. Thanks, Archer. Very good. Good catch. Okay. Now I'm going to divide everything by -4. And if there's any other mistakes that you spot, please let me know. This would be 1, 2, 0, 3. This would be 0, 1, 0, 1/2. This is 0, 0, 1, -2. And this is going to be just R2 divided by -4. Okay, last step here is going to be to eliminate the top row middle number. And I want to do R1 minus 2 R2. So this would be 1, 0, 0, 2. This would be, because it's 3 minus 2 times 1/2. This would stays the same, 0, 1, 0, 1/2. And this is 0, 0, 1, -2. And lastly, this just tells us that x equals 2, y equals to 1/2, and z equals -2. And if I had more time, I would say it's very important to check by plugging in. So maybe we'll just check the first equation. On one of my tests, if I'll give you a hint that the answer won't be a fraction. So if you see a fraction, you maybe say, okay, wait, let me check. It's really hard to spot your error in these. But as long as you kind of show me that you understand the strategy, and it doesn't seem like the numbers are getting too crazy. If you see a lot of crazy fractions as you're doing this, take a step back and try to go back like 1 or 2 steps to see if you can catch any mistakes. These are hard to do and also very hard to grade because it's easy to make like one small error that would just throw off everything. Okay, so we check the original system. Let me just look here. 2, -2. Nice, that works out. That also, okay, so just plug them all in and 4, yeah. Okay, it looks good. Oh, why did I change the 2 to -2? Oh, okay, this one, yeah, Archer pointed out that here it was -12. So how do I get this -2? This -2 comes from -12 minus 5 times -2. This is R2 minus 5R3. And this is going to be -12 plus 10. All right. So I want to move forward. And it's great, like you can actually just like if you feel like you're a little bit shaky on this, I'm only going to ask one question on this, by the way, because it takes, as you see, it can take a while to do it carefully. So on our next midterm, there'll just be one 3x3 where you have to do this long method of Gaussian elimination. So, and it might even be a 2x2, but just to keep it a little bit shorter. But it's really good practice. And if you plan to, if you're interested in this type of math, which is a really useful type of math, you will encounter this in much more detail in the beginning of any course on matrices. They always go through this stuff. So it's really worthwhile to learn it well. And I think also, I think the idea of it is pretty easy. I think it's just being careful and executing it that can be tricky, and still I will make mistakes like I just did earlier solving it. So okay, so let's talk about matrix multiplication. So matrices, so far we've just used them to solve a system by doing what we call row operations, where we can swap out rows and we can multiply through by rows. But it turns out that matrices are actually very rich mathematical objects, and they it turns out that they represent something very interesting, and they're kind of like their own matrix of numbers. You can think of it as its own number system. So each matrix is kind of like its own special number, and so if you want to add matrices, so things you can do with matrices, you're allowed to add matrices. So you can, so what is a matrix? And then towards the end of this, we'll hopefully talk a little bit about what the matrix actually represents. So a matrix is a rectangle of numbers. Or let me call it not a rectangle, it's called an array of numbers. So matrix A, let's say here, this is going to be, this is M. Let me erase this and write it over here. So we're gonna have like, this could be, let's say, 2, 2, and this could be like 4. 4. So you have 2 rows, 4 columns. Let's say this could be A, B, C, D, E, F, G, H. This is we call a 2 by 4 matrix. The first number is always the number of rows, and the second number is the columns. Or in general, we can have an M by N matrix. And to remember which one is the rows and columns, I just think about always going from left to right. So like imagine like the matrix is a block and there's a ball coming from the left side, like moving left to right. The first thing the ball will see is the rows. So that's why the first number is the rows. And then it bounces over or something, or I don't know, and then it hits and then it kind of sees the columns. So the first thing you see when you see a matrix is the number of rows, and then the second thing is the number of columns. Okay. So you can have any type of matrix that you want with integer number of rows and columns. A 1 by 1 matrix is just regular numbers. That's just boxes of regular numbers. Here, we worked with a 3 by 3 matrix, but we augmented onto it a single column. So that turned it into a 3 by 4 matrix overall. But really, what we're working with are 3 by 3 matrices. And later I'll kind of discuss what the rows and columns like actually represent. But for now, I'll show you what type of things you can do with matrices. So one thing you can do with a matrix is you can multiply it by a scalar, which means you can multiply a matrix by just a regular number. So if you have a matrix A, so you can multiply matrix by a scalar, just a regular number, regular single number. Actually, yeah. So before I do that, let's give you another thing you can do with matrices. So if you have two matrices that have the same dimensions, these are called the dimensions of the matrix, the number of rows and columns. If A and B have the same dimensions, you can add A plus B to get a new matrix C. And that's really simple. That would be exactly as you expect. So what we would write here is I'll show you a little bit of how we write notation for matrices. So if A equals A11, we index the entries by saying the first number is the row that it's in and the second number is the column. So this is the row and this is the column. So this would be A12, A13. This would be A21, A22, and A23. And if B is the same, has the same sort of dimensions, B11, B12, B13, B21, B22, B23, then C would just be adding the first entry would just be A11 plus B11. So we can write we write it like this. This is like a shorthand. We write this is a matrix consisting of Cij, where I and j can go from different rows and columns, and the formula is that Cij, where Cij equals Aij plus Bij. This is just a abstract way of saying if you have two boxes of numbers, just put them on top of each other and add the numbers, and then there you have a new box of numbers, a rectangle of numbers. You have a new matrix. Okay. So let's do a simple example. So let's say A is equal to 1, 2, 3, 4, 5, 6, and B is equal to 2, 0, minus 1, 3, 1, minus 2. What is A plus B going to be equal to? What's the new matrix? What is the first row going to be? Anyone want to message? You can message me. What's the first row? Message me when you got the first row, and then you can also tell me. Nice, good, excellent, nice, Kanjit, nice, Lily. So the first row would just be adding up the two rows. You do 3, 2, 2, and the next one would be 7, 6, 4. That's it. So adding matrices is really easy. Now, what about multiplying matrix times a regular number? So what does it mean to do 2a? Well, or even 3a. This is the same as a plus a, right? And we just saw how addition works. So instead of just adding them together, what we can do is we can multiply every entry. So 2a, using the same a that we had previously, would just be 2, 4, 6, 8, 10, 12. You just multiply every entry. Okay, so far so good. Any questions on adding two different matrices or multiplying a matrix overall by just a single number? All right, so get ready because we're about to do what does it mean to multiply two matrices? And you might think, oh, well, I know how to add them, so multiply, I just put them on top of each other and multiply, get a new number. And unfortunately, that's not exactly what we do to multiply matrices. It's a little bit more complicated. And the way I like to teach it is something called the truck into the parking spot method. So what about matrix multiplication? And for now, I'm just going to teach you kind of the mechanics of this operation. And then later, tomorrow, or maybe later today, we'll get a little bit more insight into why this thing even exists. But for now, it's just like a random process that you just have to learn how to do. And it's kind of fun to do it as well. What about multiplying matrices? Well, okay. So if we have and this is not in the book, so just pay attention to how to do this. So we do something called the truck into parking spot. So let me do the matrix A. So this is going to be 1, 2, 3, 4, 5, 6. And then I have another matrix that will be the matrix, let's say C or whatever, a new matrix. It's going to be 1, 3, 0, -1, 2, 1, 0, -2, 1. Okay. So you can't just multiply any two matrices. When you multiply two matrices, A times B, or whatever you want to name them, the way it works is you have to make sure the matrix on the left is different from the matrix on the right. So what you do is you take the matrix on the left and you take the rows, and those are your trucks. So this is truck 1, and this is truck 2. And then you take the matrix on the right, and then you have your spots, which are vertical. So like the truck, it's like goes into the parking lot, and there's 3 spots there for the truck to park into. So the spots are vertical, and the trucks are driving in, and they see the parking spots. And so the way we take the product of two matrices is the truck, each truck goes into each parking spot exactly once, and then we keep track of which truck it was and which spot it was. This is spot 1, spot 2, and spot 3. And we record that number. Oh, sorry, we're going to do something interesting when the truck parks into the spot. So the truck goes, and it drives, and it drives. This is the front of the truck, let's say, and it drives into the spot. So and then the two numbers, the truck is directly on top of the spot, and the numbers that are on top of each other, you multiply, and then you add all of those together. So what do I mean here? So the first truck 1 into spot 1, you're going to get 1 times 1 plus 2 times 3 plus 3 times 0. So, or I could write in here, I'm just going to, I generally don't like to write like this because it gets too messy, but I'm going to write here times 1 times 2 times 3. And you're going to start to do these later, just kind of do them carefully in your head and keep track of them. So if I multiply the numbers that are corresponding to the same positions together, that are overlaying each other, and then I add them all together. So this will be 1 plus 6 plus 0, that's going to be 7. And that's going to be the first truck into the first spot. So that's going to be, I'm going to keep track of that. This is the truck, and this is the spot. So it's going to be in the first entry. Oh, that's a 7. So this is the first number in my answer. Now let's take the first truck and let's park it into spot 2. Can you guys tell me what answer you get when you take truck 1 and park it into spot 2? So I get, and I'm going to start writing it here, but try to do it on your own. 1 times -1 plus 2 times 2. Nice. Anybody else get 6? So I'm taking this truck and I'm moving this truck into this parking spot here. Please hit yes if you got 6 or if you're still working on it, and hit no if you're totally lost. And so everything from the first truck, we're going to record all of the all the different parking spots it parked into and the numbers we got out. We're going to record that in the first row because it's from the first truck. So this next number would be a 6. And by the way, there's a name for this operation. Whenever you take a row and you overlay it with a column and you multiply the numbers together and you add them all together, that's actually called something called a dot product, which you might have heard of in physics, but that's a special type of operation. And that's what we're really doing. We're just taking a bunch of dot products of different rows with different columns of the rows of the left matrix and columns of the right matrix. Okay, please continue this pattern. So do the same, do truck 1 into spot 3, and then fill in the bottom row of the answer with truck 2 going into a spot 1, spot 2, and spot 3. Okay. I'll wait a few minutes. You can message me. Let me know what the for the top row what the final number you got is, and then also you can just do it and let me know which numbers you're getting for the bottom row of your answer. And if you're stuck, also let me know if you need some help. But you definitely need to do these, you know, on a piece of paper. Oh, by the way, sorry, everyone can chat. Nice, Hannah. Nice, Lily. Yeah, so the last number is 1, 2, 3. Goes into, let's see how it goes into this one. So I'm going to write 1, 2, 3. And I just look at it quickly. I say, oh, that's 0. This is -4. And then this is 3. So that'll just be, the last one will be -1. And that's it. There's nowhere else there's no other spots. So that's the end of the matrix there. But I do have now truck 2, which is going to give me the numbers for my second row in my answer. Let's see. Ivan, did you get 1? Hang on. Ivan, you're saying this? You got 1 for this number? Oh, -1. Cool. Okay, good. All right. Please continue. Please tell me what numbers you get when you take truck 2 and you park it into the different spots. And then just report to me the three numbers you get for the last row. And this way I'll make sure that you can do it, and I want to make sure that everybody's on the same page. Okay, looks good. Nice and in. Nice, Lily. And this looks kind of complicated, but once you get the hang of the pattern, it's actually really fun. And I mean, fun is a strong word, but it's not that bad. It works out pretty well. Hannah, careful with that first number. I think a little bit of arithmetic. And by the way, guys, make sure. Excellent. Nice. Nice, Shay. Nice, Savannah. Awesome. I'm seeing a lot of people get it. You guys are doing great. So the last one here is 19, 12 minus 4. Especially for this chapter, I recommend just doing like, if you can, like every day, just like a few minutes of the mental math stuff, like adding numbers, just seeing if you can kind of get your scores, the number of answers you can get in like a time, like, was it 2 minutes or something? If you work on that every day, you'll see that you'll get faster and faster at it. So it's just a good thing to be comfortable doing mental math, because if you start to write all these down, it gets really difficult. Yes, I'll share these notes also. Okay, so that's our matrix. So what do we learn there? We learned that you can't just multiply any two matrices. In particular, in order to be able to multiply matrices, and I'm going to star this comment. In order to multiply matrix A times B, the number of sorry, not the number of, the size of the trucks in A must be the size of the parking spot in B. Or in other words, the size of the trucks is the number of columns in A. So columns in A, number of columns in A has to be equal to number of rows in B. Okay, so this is the main idea here. So if A is a let's say 2 by 5 matrix, and B is a 5 by 3 matrix, can anyone tell me what you end up with? What are the dimensions, if it's possible? Can we multiply? Let me see. Can you multiply A times B, and what dimension would the result be? So take a moment to think about this using kind of the pattern that we just developed. What do you guys think? And one thing you can try to do, just sketch it out a little bit. Like can you multiply them? Yes, nice. What dimensions would you get? Not quite. So let's draw it out, and you'll see the pattern. Let me draw this out. Nice, Lily. Oh, not exactly. Actually, no, not quite. So let's take a look. So 2 by 5 means we have 2 rows, 5 columns. So I'm going to just do stars. Okay. So this is 2 by 5. Okay. The next one is 5 by 3. So, I'll do copy and paste so that I can save myself some time. So we have 5 rows, and we have 3 columns. Oops. No. Copy, paste, paste. All right. So first question is, does each truck fit into the parking spot? So does each truck that we have 2 trucks, do they fit into each parking spot? Nice, yeah, because the trucks are length 5 and the parking spots are length 5. And that happens because this number and this number match up. Okay, in our answer, when we take the first truck, how many, and remember, whatever we get for the first truck, that goes into the first row of our answer. So how many spots are there for the first truck to park in? The first truck can go into 3 spots. So the first row of our answer, this corresponds to truck 1. Our answer just records what happens when the trucks park into the spots. So the first truck records, the first row records what happens to truck 1 when it parks in spot 1, spot 2, and then spot 3. And then the second truck will also park into spot 1, spot 2, and spot 3. And there's no third truck. So that will be it. So the answer, the dimension of the result is going to be, this is 2. Let me maybe make a better color here. Color this red. This is 2. And then make this blue. This is 2 by 3. Nice. Any questions? Do you guys see kind of how the pattern results? I could have given you some numbers and just had you do it and see it, but can you see can you understand how this pattern is working and anticipate how it would play out if you have different dimensions?
I have a question.
Yeah.
So for the 5 by 3 column, do you just leave that third column alone because you never circled it or anything?
Oh, no. I definitely, sorry, my bad. Definitely it's another parking spot.
So which one would you use for it, truck 1 or truck 2? Well, like,
every truck goes into every parking spot.
so you could use any, it doesn't matter.
Well, you want to use all of them.
But there's only 2, so which one would you know to pick? Because we've already used truck 1 and truck 2 for the first 2. Which one would you use for the third one?
Oh, yeah. So like imagine the 2 trucks are coming in, there's 3 parking spots. You're just doing like the truck 1, it goes to in every possible parking spot. So truck 1 goes into spot 1, spot 2, spot 3. Then
So
you
you
go
could
on to truck 2 and you do spot 1, spot 2, spot 3.
So you could just use, oh, never mind, I get it.
Yeah, every truck has to go into, like, you can have like 1,000 parking spots. So then that the first truck would have to go into every one of those 1,000 parking spots, and you keep track of those 1,000 numbers. Okay, so by the way, so can you multiply B times A? If you have the same matrix, same dimensions, would we be allowed to, instead of multiplying A times B, can you do B times A in this example? Why not? Lily, why not? What happens if you reverse the 2 matrices? And remember, we always do trucks on the left, parking spots on the right. How big would the trucks be? The trucks, there would be 5 of them, but the length of the truck would be length 5. And if you move the other one, sorry, length 3. And if you move the matrix A to the right side, the parking spots, if you draw them as columns, right, the parking spots would have length 2. So they don't fit anymore. So when you can't fit the truck into the parking spot, you can't multiply. It just doesn't work. So that's not allowed. So we see something interesting with matrix multiplication is that you can multiply A times B, but it's possible for B times A to not even exist. So in this case, B times A doesn't exist. So it's a little strange because, you can add, we talked about adding matrices, that seemed pretty easy, but now we have this weird operation of multiplying where you can multiply in one way, but the other way doesn't exist. And let me just finish off with one last example to demonstrate something interesting, and it's a good practice as well for matrix multiplication. So let A equal to 1, 1, 2, 0, and let B equal to 1, 0, 2, 0. Let me see if that actually would be nice. Okay, let's try this out. Let's find, so the first one is find AB, A times B, and the second one is find B times A. Okay, and these will be the last 2 questions, and then I'll let you guys go. Kanjit made a good observation. So whenever you multiply 2 matrices together, if you look at their dimensions, the resulting matrix, you can just put the dimensions together, write them like 2 by 5 times the 5 by 3. The middle numbers should cancel or should match up, and then the resulting matrix will just, the resulting matrix, get rid of these 2 numbers. The resulting matrix will be a 2 by 3. The number of rows of matrix A and the number of columns of matrix B. So that's a really good observation, and that is a question that I sometimes ask as well. So excellent observation. Okay, so please, this is just a quick example. Please, for practice, let's just do this quickly, and then class will be over. Find A times B and B times A. And when it's a square matrix, that's when you can kind of switch the order because the trucks and parking spots have the same size no matter how you look at it. And let me know when you're done with these. Okay, let me kind of go through it first here. So first, I have a 2 by 2. It's a 2 by 2 times a 2 by 2. So I can say, I know that these numbers are the same. So those the truck, whenever you park the truck into the parking spot, you don't care how many numbers there are in each of those. As long as they're the same, you're just going to multiply them all and then add everything. So that turns into one number. But you have two trucks and you have two spots overall. So that's going to give you at the end another 2 by 2 matrix. Excellent. I'm seeing a few students writing the numbers in correctly here. So you do. So let's do the first one. A times B. This will be 1, 1. Take the first truck and park it into each of the spots. That will be the first row of our answer. So 1, 1 parked into here, that's just going to be 1 times 1. I'm just going to write it here, 1 times 1 plus 1 times 0. That's just a 1. Then I do the same thing with again, this this truck move it into here. It's going to be 1 and 1. That's going to be 2 times 1 plus 0 times 1. It's just 2. So that's 2. This one is nice. 0, 2. Do you guys see what's going to happen when I take 0, 2 and park it into each of the spots? It's going to become 0, 2, but that's just 0 plus 0, so that's 0. And then this is 0 times 2 times 0 plus 0 times 2, 0, 2 here. That would also become 0. So this is just 0 and 0. Yeah, exactly. That would be 0 for the two numbers there. Let's try B times A. And it might help to just rewrite it here. 1, 2, 0, 0 times 1, 1, 0, 2. So let's try it out. Now my truck is 1, 2, and I'm parking it into this spot. So, and then I'm going to park it into this spot. So 1, 2, that just becomes 1 times 2, which is just 2 plus 0. So that's going to be, oh, sorry, no, my bad. That's 1, 2. That's just going to be 1 times 1, which is 1, plus 0, which is just overall going to be a 1. And then over here, 1, 2, it's going to be 1 plus 4, which is 5. And then the last two numbers are 0, 0. So if your truck is ever 0, 0, anytime you park it, you're just going to get 0, 0, 0, 0. So those results are 0, 0. Okay. And I guess this is maybe not the best example, but the point of doing this was to show that even if you are able to multiply A times B and B times A, like they both work, and that only happens for a square matrix, it's not going to be necessarily true that A times B equals B times A. So this is a really weird thing about matrices, is A times B does not have to equal. Does anyone remember this property? What's it called when you have a number system and A times B equals B times A? Anyone remember the name of this law? Kind of like symmetrical. It is very like A times B equals B. There was a name for it. There's the associative law. Nice. Commutative. Yeah, the commutative product. So here's the moral of the story here, that matrix multiplication is a little bit strange. So matrix multiplication does not have to be, is not in general have the commutative law. Commutative. Okay. And commute things is like when when you switch the two things. All right. So next time we'll talk a little bit more about like why would you even do something like this? What does this represent? There's a lot of different uses for it. matrix multiplication, if you guys are interested in like, Tesla's self-driving thing, artificial intelligence, it's all based on matrices and doing lots of matrix multiplication. So that's kind of one motivation to learn these ideas. Oh, the property is, let me write it out a little bit better. Commutative. Or if you've ever wondered, like, how does YouTube know what videos to recommend to you, or how does Google work? Like, how does Google find the best page at the right moment? The math behind all of those questions is based on matrices and matrix multiplication. So it's a really, really useful topic to understand and be aware of. But at the basic of it, the basics of it, it's just taking the trucks and parking them into the parking spots. Yeah, a lot of algorithms, that's right, Archer. A lot of algorithms are based on matrices and in particular matrix multiplication. And in fact, Qualcomm was basically founded on something to do with matrix multiplication. So there's a lot of very valuable ideas that come out of these objects. All right, guys, I will see you tomorrow. I'm going to post the other notes, and yeah, message me if you have any questions. Please remember, those of you who came in a little bit late, if I ask you to submit corrections, please just upload your corrections. Tell me that you did the corrections, and then we'll talk about. I want those people who I asked to do corrections. I want you guys to do a retake, and you can get almost most of the points back. I want to see with the corrections that you are very comfortable with the material, and that when you take the retake, you'll almost ace it next time.
Thank you.
Okay, guys, take care. Bye. See you, Archer. See you, Allison.